Okay, hello everyone. Welcome to this R²D² workshop. Thank you everybody for participating to this event. My name is Ugo Stecchi, and this event will be recorded and disseminated through our channel. Today we are going to see. Okay, today we're going to see some outcomes of our project called R²D². Indeed, this is it was imagined like a workshop, so to have interaction with all of you, presenting some real case from solutions developed and then adopted by our pilot partners. The title of the workshop is Strengthening Energy Infrastructure Against Extreme Event. Together with me, there is my colleague Raquel Castan. She is Communication Dissemination Leader in R²D² project, and she will help me in with all the technical things with this event. As I told you, the event is recorded indeed, okay, this is the agenda for today. We will have a short introduction about the project. Then we will have three presentations from three our pilot sites. The first one is DERS Control for Flexibility and Congestion Management, presented by the Slovenian pilot Electro Ljubljana. Then we have resilience and physical security enhancement of power distribution infrastructure by HEDNO, the Greek DSO, the second of our DSO pilot. Then we have reliability of energy asset through advanced inspection techniques by EDP New, the Portuguese pilot. And then we will finish our 2-hour session with some Q&A and some conclusions. It is possible to raise your questions after each one of the presentation, and if more questions will arrive, we will take it at the end in the final slot. So we will try this way to stay within the scheduling. Also, together with me today, there is Matteo Spanteli from University of Cyprus. He is a partner of R²D² project, and he will help me to animate the debate with some consideration all along the presentation and the discussion that we will have today. Some other generic instruction for you. If you want to ask something, please use the Q&A chat that you have in the upper bar in Teams. And for all the speakers, please turn on your camera while speaking. And that's it. I think that we can start. So, okay. First of all, I want to, well, first of all, to be honest, sorry for my voice today. I'm a little bit sick, despite the heat wave that we're suffering, so my voice is not 100%. Apart from this, I want to ask your participation in answering this poll that you can see here in my screen. Raquel, if you can please share the link of this poll here that you can see in the chat. Okay, great. Thanks, Raquel. If you open the Q&A chat, you will see the link for the poll. They are generic questions about power system resilience, which is the main topic about our project, and of course the event that we are presenting right now. There are three simple questions with a close answer. How do you see which is the major challenge in power system resilience? How do you see the role of flexibility from RES and DERS in distribution systems? And your perception about the current European legislative and regulation framework. Please go to the questionnaire, vote it, and we will see at the end of the presentation what is the results and the percentage of the answer. It is, I think it is interesting since we have a quite heterogeneous audience today. There are people from university, academia, industry, system operator, research centers, and so on. So this is quite general question, but I think it is worth to have the perception of such heterogeneous audience today. Also, you can access the questionnaire through this QR code. Okay. If you have access the poll, you can start voting. Meanwhile, I will start to introduce to you the R²D² project. Okay, R²D² is an acronym standing for Reliability, Resilience, and Defense Technology for the Grid. It is coordinated by ETRA IND, the company I'm serving, and it is an innovation action with a total budget of approximately 10 million euros, 18 partners, including affiliated entities and associated partners, 4 demo pilots, and 3 years project. So we are about to finish our 3 years run. It is expected to be concluded by September 2025. And so we were able to present to you today some real outcome, real final results from our pilots. I have resumed here in these 3 bubbles, into these 3 boxes here you see at the bottom, the overall objectives of the project. So demonstration of increased energy system reliability and resilient solutions, preventing disturbances in electric system and ensure a rapid recovery after an extreme event, and of course the demonstration and validation in relevant environment, which is a core part for us in our project. That's why we also decided to give such big focus today to the activities and the experience from final users. You can see here the pilots that we have on board in our project. We have a Serbian pilot composed by the Serbian TSO EMS and the Serbian Regional Security Center SEC. Then there is the Greek pilot HEDNO, the Greek DSO. Then we have Electro Ljubljana, which is one of the main DSO in Slovenia, along with his sister company Electro Ljubljana OVE, the company devoted to managing generation unit in Slovenia. And then we have EDP New, the research center from EDP Group, along with R²D² and Labelec. R² is the Spanish DSO, and Labelec is the digital company within EDP Group. Of course, the 3 of them in Portugal. The other green countries that you see in the map are the countries where our partners belong. And in the different box, you can see the infrastructure and the asset that they bring to the pilot sites. So before going in the describing the solution that we have proposed and developed in our project, let's give an introduction. What is the current framework when we're talking about power system resilience today? We're talking about a mix of different contingencies, I would say, of different issues or problems spanning different parts of the overall infrastructure. So we have, of course, in the first part, the increasing number of extreme events. So events are becoming natural, and weather events are becoming more and more frequent, but also more severe. Their magnitude is increasing. If we're talking, for example, about wildfires, in 2024, there were more or less 1,000 wildfires in Euros, with more than 400,000 hectares burned in the European Union. And this is only wildfires. That it is one of the extreme event affecting power system. We suffered until a few days ago, or maybe till today, a heat wave all over Europe. Before a heat wave, we have wildfires also in June, affecting several regions in European Union. Uh, our company is based in Valencia, so for example, we suffered a massive flash flood all over the territory around the Valencia capital and in the region of Valencia area in 2024 fall. And these events are becoming more severe and more frequent all over Europe. And then we have also another kind of different severe events related to what can be a malicious event by man-made or man-provoked, like attack, physical or cyber attack. According to ENISA, the European Agency of Cybersecurity, in the last 2 or 3 years, a cyber attack have more or less doubled since the period between 20 and 2022, more or less starting from the crisis or the war between Ukraine and Russia. The number of physical, but also more than physical cyber attacks in energy industry have been skyrocketed. You can see here some figures about utilities. We have statistics of 1,000 weekly average attacks only in utilities in 2023, but also these attacks, which are not cyber, they have also physical consequences, and these consequences as increase of their of more than 100. You can see here the percentage, 146 percentage as physical consequences in 2024. Apart from these well, externalities, I would say there are also other factors internal to the system, to the power systems. That is the increasing of electricity demands due to the electrification. We know that we are migrating some thermal loads and also some other energy loads, like the ones connected to the mobility and the vehicles, to electric loads. Also, new loads are rising, like data centers. So the energy demand is expected to increase more and more in the upcoming years. And on the other hand, also the energy mix is evolving. Renewable energy sources are expected to increase. The new target is set by 2030 by European Union at more than 40% by 2030. And all these factors have to be viewed under this perspective of aging infrastructure that you can see here. The 30% of all the energy infrastructure in Europe is more than 40 years old. So we have an aged infrastructures. This requires a huge investment at all European level. The final numbers that was published is talking about almost, let's say, 600 billion euro to be invested to renew and refurbish or build new infrastructure in electricity system by 2030. Some other estimation talk about 1.4 trillion euros to be invested by 2040. And apart from this, there is a side effect about energy poverty due to bottlenecks and other kind of issues. So it is not a very easy situation that we have to deal with. So I will ask help now to Mateus. Mateus, can you hear me?
Yes, Hugo, I'm here.
Good
Thank you.
morning, Mateus.
Good morning.
Thanks to join us. So we have indeed a very, I don't want to say crazy situation, but it's not that easy to handle all these factors in one uh, altogether. I mean, you know, how do you see the situation? I remember Mateos is very experienced in power system resilience. Part of being professor at University of Cyprus, is also co-chair in resilience group in Sigre. So Mateos, if you want to give your opinion and vision about these figures that I've presented.
Of course, Hugo, thank you very much for the introduction. And indeed, Hugo, I mean, combining all these factors together is a big challenge. So starting from the aging infrastructure you mentioned, Hugo, about the grid modernization, as it's called, I mean, spending all this amount of money for upgrading, building new infrastructure, indeed, is a big challenge. And the big question is, how do you actually do that? So what is your main target, or what are your main targets, and how you prioritize your targets? As you very correctly mentioned in your introduction, we have increasing penetration of renewables, increasing electrification of many critical sectors, including transportation, heating, cooling, and so on, which increases the burden, let's say, on the electricity infrastructure, which is the backbone of any modern society nowadays in Europe and going beyond Europe. We also have the increasing digitalization of power systems, which on the one hand, yes, it advances automation, self-healing operations, and so on and so forth, but it also increases the vulnerability of our systems to cyber attacks and to more threats that potentially we haven't much experienced before. And also combining that with the increasing frequency and severity of climate weather-induced weather events, as we experience in Europe. Fortunately, now we see the wildfires in the Mediterranean, we see floods in other parts of Europe. I mean, there are even floods in Texas now. Also, it's not just at the European level that we're facing these issues. So aligning grid modernization, digitalization, resilience, and decarbonization, and know where to invest and how to invest is a big challenge. And I believe R²D² made a very good effort in trying to address and tackle these challenges. And I believe it's a very good step forward, try to bring together all the knowledge we gathered in the project and package and translate into the technological solutions that will demonstrate in the workshop today as hopefully readily available tools for system operators and planners to actually apply and try to tackle these challenges looking ahead in the future. Thank you, Hugo.
Yeah, indeed. Thanks a lot, Mateus. We will present. We will say at the end of the presentation how people or audience can get in touch with R²D² and where to find our outcomes, the outcomes of our work for what as you said.
Yeah, and Hugo, if I may add, because you
Yes.
mentioned SIGRE, IEEE, and so on, I mean, I and other members of the consortium are heavily involved in these kind of international professional bodies. And these challenges are really rising, let's say, in the agenda of system planning regulators around the globe. So we hope that the project will have an impact in the longer future as well. Thank you, Hugo.
Yeah, indeed. Thanks, Mateus. We try to do our part in this
Yes, indeed.
big picture. So moving on. Okay, I will give you a brief introduction of the technical solution we developed within R²D². We have four different big products that we have designed and developed. The first one is called C3PO. It is called Multi-Risk Assessment Framework for Power System Resilience. It is composed by two different sub-products. The first one dealing with cyber risk assessment, while the second one with the physical and operational risks. Then we have IRIS, resilience, that an acronym standing for Resilience Suite for TSO and DSO. Here we have developed solution for coordination between DSO and TSO during emergency or critical situation, or even for TSO and TSOs during the same conditions. Then we have PRECOG, that is our main product devoted to the cybersecurity aspects. We developed several tools or macro functionality that you can see here listed, basically to secure the communication in IT and OT systems, to inspect and analyze IT and OT traffic, and secure the connection of new equipment and the supply chain. Finally, we have EMMA, Enhanced Maintenance and Asset Management Toolkit, which is basically a tool composed by a set of functionalities dealing with unplanned outages. The first one that you can see here in the list, including functionalities or tools dealing with drones, thermal and RGB cameras, and AI tools to analyze those acquired images, and other tools with dealing with planned outages, like outage planning scheduler, dynamic live rating, transit stability, and topology transfer. So regarding the scope that we are trying to embrace in R²D² project, our ambition is to cover the events spanning from high frequency, low impact events, so common outages that are affecting just a small portion of the system, up to high impact, low frequency event. Those kind of events that used to happen once in a while, but once they happen, they have a disruptive effect and impact over the system, like the one that we suffered in Iberian Peninsula at the end of April. And the different solution within R²D² project are imagined to cover or to bring to support system operators during the different stages or phases of the event, before, during, or after the event. Another aspect to consider is that we are trying to cover different risks: cyber risk, physical risk, weather risk, and natural risk. Since all of them have side effects or impact each one to the other, so we need to have one unique view on how to approach them. So I will start now to introduce the different use cases that the use cases presentation of the pilots. We will start with Electro Ljubljana. We will see three solution for improving low voltage observability, DSO, TSO congestion coordination, and tokenization of grid balancing data. Then we will jump to EDNO with some presentation about substation physical security and modeling of extreme event. In this case, we will consider a windstorm with some proposed solution to minimize the impact of this extreme event. And we will complete the presentation with R²D², in particular with the pilot, the Portuguese demo, with the overhead lines inspection and health of critical component in substation. So I will give the floor now to Electro Ljubljana Yuri Zurk. Can you hear me, Yuri?
Yes, I can hear you.
Good morning, Yuri. Yuri is has 30 years of experience in the electric industry. Since 2018, he is advisor of the board Electro Ljubljana, responsible for technological development of the company, including new technology, and he is responsible of different smart grids and innovation project at Electro Ljubljana. Yuri, if you can please share your screen and start your presentation. Also, if you can turn your camera on.
Yeah, I can turn my camera on. I hope this works. The problem is that I was not using the original link, so I would ask you to allow me to share my screen because I'm just a normal participant in the call.
Okay, now you're. I converted you as moderator. You should be able to share your screen.
Now I can do that. Yes, thank you. So I guess you can see now the screen. And if we go like that.
We can see that, but not in presentation mode.
Yeah. I'm doing it. I don't know. Yeah. No. Shit. No. Yeah, okay.
Great.
That should
Thanks.
work, yeah? Sorry for this. Yeah, okay. Some information about the Slovenian pilot. Okay, the participants here are Electro Ljubljana's DSO with our grid and our daughter company Electro Ljubljana Obnovljivi viri energije as owner of several renewable sources involved in this presentation. I mean, in this project, and 3 technology providers for different use cases, ELPROS, ETRA, and GUARD. Okay, I suppose we don't have that much time. Of course, pilot assets are now used in this project are 20 medium voltage to low voltage transformer stations, including their connected low voltage grid and connected grid users that are consumers, generators, prosumers, and from the generators especially involved are 4 renewables. This is 1 small hydropower plant and 3 PV installations, all related to some of these 20 medium voltage stations, a low voltage grid. Okay, well, I will touch somehow this 4 use cases related to the problems in our network from the involvement of renewables in system services, then to security when connecting different critical systems of our IT infrastructure, lack of information exchange between TSO and DSO in case of restrictions in DSO grid, and potential manipulations of the traffic light system messages that events that can affect the operation itself, security itself, but also the let's say a financial side of all that. And in principle, all this is connected with the data flow data traffic between the systems involved. And we start with collecting the data from the meters. We have like 95% now of smart meters, but smart meter is not necessarily connected to the metering system by real-time data connection. So most of the meters are collected, the information from them, even if in the time interval of 15 minutes are collected only once in a day. And what we needed here is to have also some meters that use 1 minute time resolution, so that we have close to real-time data from them to see what is happening in the network. And of course, meters are in their own specific communication world with DLMS-based solutions. Here is example of one message, and then we can go on further. We need in our metering, let's say, metering system, we convert the data then into a form which is more used for flexibility management, and I mean more appropriate for flexibility management and for exchange of information between different other, let's say, stakeholders. And this is XML-based message queue technology. And but why we need this data is to have a better estimation of the situation in the low voltage grid. And this is why we then further send this data to the advanced distribution management system, where the function of state estimator gives us a better view of the situation in the grid. And here again, the transformation of the data is into the this communication used for SCADA, actually telemetric communication. This is TSC.2 protocol in this particular case, which is normally used for exchange of the information between the control centers. And here, what is going on, and it's basis of our here idea in improving the view of low voltage and to have then better security in the grid is, if we have here, I hope you see this pointer. This is like transformer station, and then we have houses in the low voltage grid. And we don't have a real-time measurement from this location. And if we put here some meters in the optimal locations, then we can, with the algorithms used in a state estimator, have quite good estimation of voltages and overloadings and so on in the grid, which is then the basis for some of use cases we're using here. So these data are then sent back again to this, let's say, XML world, where they can be further distributed, because we get from the state estimator much better information that we used to have now. What is the situation regarding the overloadings, voltage limits, violations, and so on. Have, let's say, also better security of the customers regarding the power quality, because they can be affected with bad power quality. And here, this is then used for let's say, automation or activation of these renewables in the sense of helping us with better management of the system, and with avoiding of overloadings and so on, because we can affect the renewables, or we can affect flexible loads in the other cases, or anything else which is flexible and we can operate or can coordinate that on the market principle basis. Why we used this particular renewables from our, let's say, daughter company is that they were actually only ready to do that because you know that renewables are so far to a certain extent subsidized either with feed-in or with certain others kinds of subsidies. And so in principle, at the moment, unfortunately, they are not really too happy to participate in the system services because they earn better if they don't. And the other example of how this data from the state estimator can be used is, of course, for all the other stakeholders in the system having some flexibility resources engaged in our grid. This can be like TSO or aggregators delivering services to TSO for the purpose of the, let's say, system services, or aggregators or whoever can also be engaged in balancing market with these flexibility resources from our grid. And of course, so far, they didn't get any information if they cause with this action additional problems in distribution grid. And this is why this is another use case, 11, in this case, TSO-DSO coordination, where through the traffic light system, the DSO or any other actor in this market can be informed about what is going on in the distribution grid, and if these distributed resources in particular part of the grid could be used for any intervention, or at the moment they should be somehow blocked, because otherwise this could cause a problem with power quality or even outage of the system due to operation of protection. And of course, since all this, let's say, influencing all these flexible loads, generators or whatever in the grid, is also related with certain payments and so on. This is quite important that these messages and commands are not manipulated. So another case that was demonstrated or is demonstrated in our pilot is then tokenization tool to get messages which have really proper. I mean, the receiver of this message is sure that the message is pure and is not manipulated and so on, and that it should react according to this command. Either is only a traffic light system or is really the activation of some flexibility. And so I hope this was quite general, but it gives you an idea of what was demonstrated in our pilot.
Thank you very much, Yuri. Very interesting indeed. I don't know if we have questions from audience. Let me check. Okay, yes, we have one question from Sayed Zina Shemi. I hope pronounce it well. Sorry. What grid services are provided? He's asking Yuri, and how do these DAREs respond to market signals?
Well, this is a question to me.
Yes. What grid services are provided, and how
Well,
these DAREs respond to market signals?
Yeah, okay. In principle, we as a DSO are using only the activation of flexibility in low voltage grid in case of congestions. In principle, so far the grid is okay, in okay state. We shall not interfere with the free market on electricity and services, of course. But if we come to situation that our grid is operating outside the limits of the power quality, that means, or it is the certain components are overloaded, then we activate these resources that can either reduce or increase power to have this congestion controlled, and that there is no overloading anymore. This is what at the moment is going on. We have also some. We are working also on the services dealing with the power quality. I mean the voltage quality, but here situation is a little bit more complex, and we need to add a bit more of study in it.
Okay, thank you. I remind to the audience that at the end of all the presentations, we will share with you our channels, so you can get in touch with us, any additional questions or information you would like to know, and then we will forward your request to the partners that is interested. Sorry again. Another questions from Shahabedin Kamyab Yuri. Is or she is asking, with the tighter TSO-DSO coordination and real-time data exchange, how do you address the increased cyber attack surface, especially the risk of an attack on one domain propagating into the other? That's a critical question indeed.
Yeah, okay. This is why we this is this use case 10 actually, which is not directly connected with TSO-DSO coordination, but is connected to our internal systems, because in DSO, at least from our perspective here from Electro Ljubljana, the most critical systems are, one is metering system, which is based for billing system, and from the data collected in here and manipulated in here for further use, depends like 350,000 electricity bills every month, you know. And this is one crucial component due to a huge, let's say, money flow behind. Then the other, of course, is control center. I mean, remote control of the whole system, which again can switch off practically the whole power supply to, again, all these 350,000 customers. And what we did through this project is that we made connection between these two systems secure. I mean, much more secure than before. And because now we expect that more and more data will be exchanged between these two systems while like 3 years ago or 4 years ago, no data exchange were in place between these two components. And regarding DSO coordination, of course, if we send information to TSO that certain resources in our grid cannot be used for system services at particular moment, this should be, I mean, it's not that critical. It would probably not switch off the whole our network, but it is critical in the respect that probably someone needs to use then another resources to achieve the same goal, maybe in the frequency balancing and so on. And in this respect, probably these other sources are not on his priority list because maybe they are less energy efficient, they are more expensive or whatever. And so again, this tokenization of these messages is important from this perspective. I hope I answered the question.
Yeah, indeed, Yuri. Also, if I may compliment for answering to Shabedin Kamiab, we have also other product and tools. In this case, what Yuri was mentioning was presenting before was related also only to one functionality within the PRECOG product. We have other tools within the same product tested in different use cases. Of course, we cannot present everything right now here today. And this is more dealing with the traffic exchange between or among servers from one or multiple stakeholders, and the inspection of this traffic and triggering alarm in case of an alert of suspicious traffic is detected. It is possible to find more information in the documentation that we've published. I would take maybe one more question because we're running out of time. Yuri, if you agree.
Yeah, sure. Yes.
Okay, then we will save your questions for the Q&A session if there is time to answer to all of them. If not, we will save them and we will send you an answer. So I will ask help to my colleague Raquel to take note to the question if I miss something. Well, I see also an hand raised. Maybe somebody who did not use the Q&A chat box.
Yes, we have hands raised. Andrew?
Yes, good morning to everyone. I'm from Slovenian company LS, which is combined operator, and I must say that this solution is very useful and we are welcoming such solutions, not only in the direction of bigger observability, but what is really important here is that we get information directly from the distribution network and together with aggregator, for example, from which we are using services that they are able to estimate on which asset they can count at. So we are really welcome this solution. This is more uncommon than a question at this session. Thank you.
Okay. Thank you very much. Very welcome your comment. I mean, it is a feedback for us, for ELEC, and for all the project that we are moving towards the right direction. Okay, Yuri, I see more questions, but unfortunately, there is no time to answer all of them, at least now. If you please can stay until the end of the meeting. If there is time, we will recover these questions at the final Q&A session, okay? Okay, thank you very much, Yuri. Now we will move to the Greek pilot presentation from Hedno, the Greek DSO. Today we have a shared presentation by Viktoras Papadimas and Theophanis Kontopoulos. Viktoras is an electrical engineer working at an EDNOS strategy, operational planning and transformation department, serving in the PMO office, while Theophanis is in the research and innovation department within EDNO since 2021, with several research and innovation project experience. Viktoras and Theophanis, can you hear us? Can you hear me?
Yes, hello, hello everyone.
Hello, Viktoras.
Hello everyone.
Okay, please share your screen and you can start your presentation. Consider you have more or less 20 minutes for your presentation, since I can see there are questions may arrive from the audience.
Okay, can you all see my screen?
Yes.
Okay, so hello everyone again, and thank you for being present today. I'm Victor Papadimas, as Hugo said, and I work for the Strategy, Operational Planning and Transformation Department of HEDNO. As Hugo said in the beginning, HEDNO is the Greek DSO, meaning it's the owner and the operator of the electricity distribution network in Greece. The colleagues listed here are part of our internal team working on the R²D² project, and they come from different departments like strategy, research and innovation, and IT in general. First of all, the Greek pilot of the R²D² project is based in the region of Xanthi, as you can see in the image on the right. Xanthi region is in the northern part of Greece, meaning that it's known for an area that it's exposure to extreme weather condition and thus for the grid vulnerability. In this presentation, we will give you an overview of the pilot's infrastructure, the equipment installed in the framework of the R²D², and the tools that we are using in order to address the key challenges related to resilience, security, and predictive maintenance. Our company is the end user in this pilot, and we are working closely with the colleagues listed here. More specifically, we're working closely with TETRA, which is the coordinator and developer of the project and developer of the EMA tool. ICCS and University of Cyprus are our academic partners contributing to the development of the C3PO. Cybernoises and Imperial College of London are also providing core technology for the C3PO, and last but not least, GuardTime, who are the technology providers for the PRECOG tool. The pilot site in Xanthi mainly focuses on 4 key objectives. First of all, enhancing the physical security of the substations. Secondly, enabling a predictive approach to asset management, mitigating also the impact of the extreme weather events on the network, and finally reinforcing the cybersecurity resilience in both IT and OT environments. These goals closely align with the R²D² mission in order to build a more secure, resilient, and intelligent energy grid. And in this context, we have a total of 15 use cases that will be tested as part of the Greek pilot. So now we have here a look of the Xanthi pilot site infrastructure. The pilot consists of 3 medium voltage lines, which are supplied by 2 high voltage to medium voltage substations located in the Xanthi and the Magiko area. The Magiko is a suburban and rural area near the region of Xanthi that contains a lot of renewable energy sources. These lines collectively feed around 247 medium voltage to low voltage substations. And on the right, you can see a single line diagram of the medium voltage feeder, the 33X, which gives a sense of how big and how complex is the grid there. You will also notice the table of the rated power per line, which ranges ranging from 16 to 30 megavolt ampere. Also to support the real-time monitoring and the operational planning, we have an AMI system covering around 58 medium voltage and major low voltage consumers and producers, including 39 renewable energy sources units. These smart meters provide measurements such as active and reactive power, and also for some customers, voltage and currents with around a 15-minute time granularity. The region also has some significant renewable integration with 39 telemeter photovoltaic units and 2 biogas plants. Lastly, from a previous Horizon project, the XFlex project, we have some monitoring equipment in 5 medium voltage to low voltage substations, and also some SLAM meters, which are some high frequency meters selected to some customers, to some selected customers, and also to the head of premises and in an electric vehicle charging point in Xanthi. These devices in general are owned by ETRA, and they sample data every 15 seconds and transmit it via MQTT protocols to the ETRA server. Regarding the software that is involved in the ecosystem, we have, of course, a SCADA system to supervise the 3 medium voltage feeders, the 33, the 39, and the 42 lines. The system is supported by a DMS capabilities and is integrated with remote terminal units, giving us a complete visibility and control across the network. Also, its medium voltage line is mapped in KML formats, as you can see on the right. And in parallel, we also have some single line diagrams, as well as some detailed topological representations that we have made in the Visio. In addition, we use the outage monitoring and reporting system, which can be used to provide data regarding events that lead to outages. Also, for example, some metrics like the SciFi metric, which is important for the DSO, is directly available through this system, covering both extreme weather events and other type of events as well. Sorry. And also I wanted to say that all the metering data, both from the SCADA and the AMI system, are stored in a secure and isolated environment that allows us to share and analyze the data safely for research purposes only. And now the needs of the Xanthi pilots, we have identified 4 key areas, each addressing some specific vulnerabilities and offering some benefits, targeted benefits for the grid resilience. First of all, the first need is related to physical security. This comes from risks such as intentional attacks or natural disasters that can damage both the primary and the secondary substation. To face this, we have identified the need for additional monitoring and inspection equipment that can protect the grid infrastructure. The second area that focuses on the asset management, we have many components that are installed in remote or inaccessible locations, making regular inspections difficult. Thus, a predictive and data-driven approach is necessary in order to monitor these assets and optimize the maintenance planning. Next, we need to face the extreme weather events. For example, we had during the 2021 a snowfall in Greece, and then more than 250,000 households were left without power. And to prepare for such events, we need to develop resilience operational strategies supported by proactive planning. And finally, we address the cybersecurity that which becomes increasingly critical since we install more and more IT and OT systems. Finally, we'll give you an overview of the equipment that we have installed as part of the Greek pilot in order to support the use cases in the R²D² project. In the Magiko substation, we have already successfully completed the installation of four CCTV surveillance cameras. These cameras are connected via the RTSP protocol and provide some real video streaming to ETRA. Their main purpose is to enhance the physical security, which focuses on monitoring the substation, as you can see in the picture on the left. At the same time, they offer some valuable visibility into other critical phenomena, physical, like smoke or fire near the substation that can damage the equipment. And also to further enhance the pilot predictive maintenance capabilities, we have purchased and installed a thermal imaging camera that you can see in the second picture. These cameras support the thermal inspection at the Magiko substation and also at the overhead local network. And we are also planning to deploy 3 radar-based sensors at some selected medium voltage, low voltage transformers within the pilot area. These are some devices that are equipped with some multi-zone monitoring, and they are used some 4G connectivity. For example, if in the event of a potential vandalism or a theft, these sensors will allow us to pinpoint the exact location and minimize the effort for the restoration. And lastly, in order to safely test all these and validate these tools, we have created, together with the ICCS, a dedicated staging environment that emulates both the SCADA and the SCADA system and the AMI infrastructure. This enables us a safe evaluation of the cyber threats and testing some new technologies. And now that we have seen the environment in the Greek pilot, my colleague Fannis will walk you through some specific use cases and will share some key achievements that we have seen so far in deploying the R²D² tools.
Hello from my side as well. Yes, I would like now to continue the presentation. Second part involves presentation focusing on 2 use cases, which involved both new equipment installation in the context of R²D² project, as well as integration with innovative tools developed by ETRA, for example, for EMA tool, and developed by UCY for C3PO tool that we will mention later on. So to begin with, our first use case has to do with physical security enhancement in core network components. This is subdivided into 2 main scenarios. First one is related with physical security enhancement in primary substation, and mainly in the high to medium voltage substation located in Magiko. The use case is led by ETRA, which develops EMA tool, and it's tested in the context of Xanthi pilot in Magiko substation. The first step of this use case was the installation of equipment involving 4 CCTV cameras in the Magiko substation area. We had first of all to select the exact location points where the cameras had to be installed. The criteria was the prevention of potential security breaches. So some cameras had to be installed in the side where the main entrance of the substation is located, as well as focus on some phenomena that are related to fire due to presence of small animals in the area where the medium voltage line are fed by the substation switch gears, and would like also to add some monitoring there. So totally we installed 4 CCTV cameras, and we also procured and successfully installed a local machine, which is a PC dedicated for R²D² project, receiving the image and video on 24-hour base. So this image through RTSP is forwarded to ETRA, to EMA surveillance tool in particular. EMA surveillance tool is a tool which is trained with AI algorithms that has the ability to detect incidents when processing an image. This tool is trained by AI algorithms in order to classify the incident identification into 3 categories. First of all, it can identify presence of animals. It can also identify a human. Furthermore, it has a potential to identify presence of smoke and potentially fire. The incidents can be visualized into Ether tool, and in case the DSO needs to react by applying and allocating workforce, a human tool developed also by ETRA can be deployed in this case. During preliminary demonstration of this tool past months, some tests took place in Magico substation, and as you can see, the tool was able to successfully detect presence of little animals such as birds, which were detected near the lines, or presence of potential human security breaches by human. Furthermore, during final demonstration, we will have the potential also to potentially detect presence of smoke in the substation. You can see also in the right part of the slide an image provided by Ether tool visualizing all incidents which were identified through this preliminary demonstration process. The second scenario of this use case is mainly focused on secondary substation, mainly aerial medium to low voltage substation located in Xanthi pilot lines. As far as this use case is concerned, the first step was a performance of vulnerability assessment and risk analysis, which was successfully carried out by the local head in Xanthi region department. This process focused on identification of 3 points, 1 point per line, where frequent phenomena of aerial substation thefts take place in the Xanthi network. And at those 3 points, the target was to install some sensor devices, which also my colleague Victor mentioned previously. These devices, as Victor said, have also been deployed in similar type devices in other lines, not in the 3 lines of the pilot, and they come with their own dedicated application, and they're equipped with a SIM card, which sends a 4G signal indicating the health status of the substation. You can see also indicative screenshots on the right part of the slide, the pictures, and the purpose is to install such sensor devices in 3 points of the pilot lines to identify potential theft attacks and the potential incidents of substation damage during the final demonstration phase. Moving on to the second use case that we'd like to focus on today, this is the prevention and mitigation of cascading effects in case of extreme weather event. It is a resilience-based use case, and it is very crucial for all DSOs nowadays. The developer of C3PO tool, which was involved in the use case, was the University of Cyprus, and its main objective was, first of all, the spatial and temporal event and fragility modeling, as well as the cascading modeling and quantifications that will be presented briefly in the following slides. To give you a brief overview of this use case, the first tool which is deployed is an advanced weather event simulator, which is capable of generating historical and random wind events in a spatiotemporal manner, followed by a fragility impact assessment of weather events, coupled also with the cascading and machine learning models. Another part of this use case is simulation of potential microgrids that can be formed in case of extreme weather event, in case of outages with power exchanges between each other, to potentially explore flexibility and resilience enhancement of the network. The tools also has the capability of quantifying some crucial KPI indicators for the DSO, such as energy not supplied. This tool has previously been successfully tested in IEEE test system, and the purpose within R²D² context is to also test it in Xanthi pilot line 42 Magico, which is basically a 125 bus Xanthi distribution network. The first model that the first tool that has been deployed is the spatial and temporal weather event simulator and fragility assessment. You can see some indicative screenshot in the process of how the tool works in this slide. In the upper part of the slide, in the first picture, you can see that the first step is the spatial and temporal modeling of the event. inputs from DSO or external encoder service provided is given, and the propagation of the event can be modeled by the tool. The second step, as you can see, is the fragility assessment, where the fragility curves of overhead lines are generated, and the quantification of results regarding network status in a time series format is available in a matrix format, as you can see in the picture in the center of this slide. You can see a matrix where the rows depict the time intervals, and the columns depict the buses of the network. So in case infrastructure damage in a bus occurs via the simulated propagation of the event, then you can see by red color that a damage has occurred in a specific bus at a specific time frame. Furthermore, the final stage is related with quantification of KPIs such as energy not supply indicator. The second step is also the involvement of the AC cascading simulator, which is coupled with the aforementioned windstorm event simulator. And the purpose is simulating the wind-induced cascading outages. This tool is capable of modeling the spatial propagation of cascading outages across the system, including various protection mechanisms. Furthermore, it's capable of quantifying various cascading metrics, such as the islands form, number of protection operation, and load shedding. Those tools is equipped with machine learning applications, which are used basically for the identification of critical power system components, as well as the accurate prediction of bus load shedding in the simulated network. An innovation that has been deployed in these tools is also the investigation whether the machine learning systems, which monitor the operation of power system, are susceptible also to malicious machine unlearning. The final stage of the use case involves, as mentioned previously, the formation of some network microgrids which work under emergency operation, and the power exchanges between them are simulated and investigated for potential resilience enhancement, operational flexibility enhancement in the network. Furthermore, the potential of reducing some load shedding is investigated through this microgrid formation, as well as we explore some potential benefits that we can have as DSO by reducing our operational cost. An indicative screenshot of testing in Xanthi network is shown in this image in the right part of the slide. You can see an outage that is simulated by a windstorm event, and 6 microgrids which have been formed with power exchanges between each other for the resilience enhancement and the reduction of load shedding in the network. And to give you an overview of the preliminary demonstration phase that was carried out in the past months with the help of University of Cyprus, the first step was as a DSO to feed the tool with some valuable network data and topology, production and from PVs, consumption of major loads. Furthermore, some parameters of a windstorm, a potential windstorm to be simulated was given in the tool by either DSO or external service weather provided data, and the tool was able to successfully, first of all, conduct fragility driven impact assessment by providing the fragility gears for overhead line, as you can see in the right part of the slide. And regarding the results that we obtained as an end user through an interactive UI developed by UCY, you can see that line status is available in a matrix format as explained previously. Furthermore, information about failures is also explicitly provided to the end user. The propagation of the event and the location of the bus of the network can also be visualized through this user interface. So, and furthermore, this is accompanied by curves regarding load shedding that potentially has occurred in specific buses. The preliminary demonstration simulation showed some promising results involving basically up to 40% reduction in some cases regarding load shedding by involving the simulation of microgrid operation, which exchange power between each other and work under extreme weather, under this extreme weather event, under extreme mode. And furthermore, some notable results were obtained regarding potential reduction in operational cost of the DSO by means of reduction of energy not supplied through these microgrids. And to wrap up, some key outcomes.
Yes, please, sorry.
It's last,
Sorry,
last,
okay.
yeah.
Please conclude.
Yeah. Yes, to wrap up with our presentation, we had a chance as a DSO throughout the project to share our network data topologies and explore and interact with some innovative state estimation tools and AI tools. We had also the chance to explore network flexibility scenarios such as the macro mentioned before, install some equipment for physical substation and security enhancement in the network, and the future research could also involve some broader data sets towards the state estimators involving escalated low voltage monitoring in the pilot lines, as well as the involvement of other assets such as battery storage in network microgrids to explore further flexibility potential for the network. Thank you very much. That was your presentation. Thank you very much for your time.
Thank you, Theophanis. Thank you, Victoras. Well, it seems a very high margin in KPI reducing from what you presented. I would invite
just a second.
audience to please mute your microphone. If you have questions, write in the chat. I would take one question I can see in the Q&A window here from Marta Bernal Sancho. How are the EMA surveillance algorithms trained to detect fire or smoke? Victoras and Theophanis, if you want the help for answer to this question from a technical personnel from ETRA who developed the algorithm, I can give the floor to my colleague Lucas maybe to answer to this question.
Yes, since this is a technical question basically for the training of the tool, yes, if Lucas has...
So I will ask Lucas Pons, my colleague at ETRA, who participated to the development of this AI tool. Lucas, can you hear us? Hello, Lucas. We cannot hear you. Okay.
Hello?
Second. Now we can hear you, yes.
Can you hear me?
Yes.
Okay.
If you would like to say something about the training of this AI tool.
Yes. Okay.
And especially if it, smoke or fire or both.
Okay. Yes, for the detection of animals, persons, or birds, we rely on YOLO models, which are quite mature and produce very good results. For fire and smoke, we build our own model based on images taken from scientific data sets. And we train ourselves with this data because we cannot rely on this system to produce fire or to wait until we have something similar to fire or smoke for training. So we rely on scientific data sets. We gather, I guess, around 1,000 images tagged with these two categories, and we basically train this model. We had an accuracy of more than 95% on the detection of these categories. And okay, it was something quite usual in the AI technique. We do not use anything very, very extreme. We simply train with the scientific data.
Okay, thank you, Lucas. Marta, I hope we answered to your questions. If you have or if you want more information, feel free keep writing, I mean, in the chat box, or feel free to contact us. Okay, I will move on now forward to the next presentation. I see there are other questions. I will take it at the end of the last pilot presentation, since we have to stay within the scheduling. I'm referring to Javad Nayafi. I will take your question later on if possible. For now, I would like to introduce to you Motaz Ayad from EDP New, the coordinator of Portuguese pilot. He represents EDP in several research projects, including R²D². He works as R&D engineer in the R&D department of in Portugal, with expertise in power system, offshore wind farms, and hybrid HVAC/DC networks. Motaz, thank you for joining us. The floor is yours. If you would like to share your screen and start with your presentation.
Thank you very much.
I can ask you to stay within the 20 minutes as for the rest of the pilot.
Sure.
Thank you.
All right. Thank you very much, Hugo, and thank you all the attendants for joining this session. And I hope you're enjoying and getting interest in all the topics that we have presented today. So just to start, we are mainly focused on the reliability of energy assets through advanced inspection technologies. And that's where the scope were in the Portuguese pilot. And in short, my name is Motaz Ayad, and I'm representing ADB in the project and also the Portuguese pilot in the project. So just to kind of refreshment on the first slides. So the ADB New is the project is the pilot coordinator in Portugal, and R²D², it's where the host is hosted the assets that we are using on the pilot. And ADB LabLake is an affiliate entity that is relevant to providing data and support. So, and the Portuguese pilot bill is set on two different assets. One is the overhead line exists on Obidos, and the other one is substation in Almere. Both are bid south a bit of Portugal, like around Lisbon. And the objectives that consider these two assets is mainly to use kind of a drones inspections to provide a less, let's say, called maintenance cost, and also to overall reduce the outage that could happen due to the blackout, to the breaks of the assets. So to proceed, the first asset that we have, which is on Obidos, it's a 30 kV overhead medium voltage line that is quite 69 kilometers in length. 45 of it is actually overhead, and it's mainly going through a forest, you can call that way. So it's very affected by vegetation effects. And this line is mainly supplying 2,600 inhabitants from the total of 15,500 from the main substation. And this asset mainly uses the tool called EMA Argos that we're going to see in a bit in a specific use case. Just to give a bit about this substation, so we can see it's a quite rural substation where we have some lines already going through forests, as we can see on the right side. The second asset that we have in the Portuguese pilot, which is the substation that exists in Almere, and this one, the 60-30 kV substation with a total of 30 MVA rated power. It's a semi-urbanized city, so it kind of have some kind of also rural areas, and it contains overhead and underground lines. Mainly, this substation covers 3,000 residential customer and around 30 industrial and business clients. This tool or this assets already uses two different tools. One of them is EMA Surveillance, which already got introduced in it on the Greek pilot, and also EMA Dyma tool that we're going to see also in a bit. Just a bit also about the assets that we have in this substation. So we have two transformers. This is one of them, and also different isolators, equipments as with circuit breakers and other equipment inside the substation. Just to give a bit context on the first use case, which is relevant to the first tool, EMA Argos mainly, which is mainly focusing on overhead power line inspection. As we are already aware that power grids are really expanding and becoming more complex and providing burden on the inspection and the maintenance procedures. And they are very vulnerable to faults, to vegetation interference, and environmental wear, mainly for weather conditions could be. And the current traditional inspection methods are slow, costly, require people to go, and sometimes even to a hazardous area. So that provides a main problem that the manual inspection or the labor is quite labor intensive so far. And we are talking about mainly it's possible to cover 16 kilometers a day with keep in mind an error prone. The data analysis also, the collected images by manual collection, let's say, is quite slow, leading to delay to the maintenance. And lastly, we are already lacking the predictive tools results, which is basically make the corrective maintenance unplanned. And that takes us to the solution that we are providing in MRs, where the first, that it's enabling the methodology of using UAVs based like drones to do the inspection in an autonomous way, collecting images like RGB images and infrared images, so thermal ones, and also LiDAR data. And the second part is that we are using also an AI-driven analysis in order to define the anomalies and prioritize the maintenance actions, and that's reduce the other part of the manual analysis of the images. What we expected, so on the solution that can be covered more than 30 to 50 kilometers a day instead of 16, with even a quarter of the actual cost for doing the manual methodology. And ensuring that we are aligned with the Directive Article 13 for the resiliency by enabling this predictive maintenance and being proactive in the intervention of any kind of faults that may occur. Here, for example, we are seeing the R²D² tool user interface, which is very friendly, that is basically asking you to upload the images, the data that you are collecting, like images, videos, LiDAR data, and it will automatically establish the structure from LiDAR data, for example, of the towers, the lines, and in this image, for instance, we are already seeing the lines and the tower, where they are getting closer to vegetation encroachment, and the distance between the lines and these trees or plants and so on. Another part of this tool is mainly the structural anomalies, which is detecting breaks, faults on isolators, for instance, that mainly uses the RGB images, but of course they have to be GPS positioned, so we can easily recognize the location of these assets or these components, which is, again, it's using AI model to detect all this automatically. Another part of this tool is using the thermal images, not the RGB one, also to detect any kind of protection of faults or change on temperature that may affected by kind of weather conditions. So in general speaking, that can also lead to a kind of fault and bring alarms as required. That's mainly for the first use case that is applied in the Portuguese pilot. The second use case, it's more or less similar, but on a substation level instead of overhead line. So the context is quite similar, that we already have an infrastructure that is more than 50 years, and mainly for the substation. They require of manual and periodic inspection of the substation is quite burden. And we are already started to digitalize these substations in the past 10 to 15 years, but now we are considering actually to use AI models and the advantages of the AI and the autonomous inspections to save even more on the side of the substations inspection. So the problem is we are trying to avoid the manual inspection and the time consuming required for that, and the travel that may be involved for remote access of the faraway locations. Ensure that we can have real-time monitoring and basically reducing the risk of unexpected failures, And lastly is in practice, and the current digitalization is still not sufficient to build a robust predictive maintenance, and that we are trying to provide now as a clear solution. And this solution is divided into two tools. So EMA, which is basically uses the cameras, it can be fixed or mobile cameras to capture thermal images from the substation. And that will enable predictive maintenance with an AI model to detect the change of the behavior of the assets, like if the transformer start to have kind of a different expected behavior that could flag some kind of high risk on the components and the future operation. And the second one is the MS surveillance, which we have already seen in the Greek pilot, that is basically detecting the wildfire smokes or unauthorized access nearby the substation. These two tools together, they cooperate and ensure that we are aligned with the Directive Article 13, that is, again, increasing the resiliency of the grid. And just to see some kind of results already, so first of all, detecting the hotspots on a substation, as we can see, it's similar, has a similar interface of R²D², where you upload again the images that are collected from the substation. In the Portuguese pilot, we are using drones as a kind of change to check this new approach and new concept of using drones inside the substation, not only in overhead lines, to collect images, thermal RGB images from the assets of the substation, and trying to evaluate the status and predict the conditions. And in this case, we are only seeing the thermal effects that are detected. This thermal information are collected to build a thermal care for the assets. Mainly, I would say the transformer at this stage, and the nearby assets of the transformer, like insulators and circuit breakers. And this information are provided to build what we can call the health index, the health index of the transformer, that will be based on AI that basically collect the triggers that are coming from the change of temperature, let's say, on the transformer, and accumulatively over time they can predict if there's something serious that is requiring a fast action, or if it's just a normal procedure due to the weather. So there are different inputs to this feature, mainly the images that we already said, the SCADA, like real-time power flow, and also weather conditions, just to check if it's just because of like heat weather, it's a heat wave as currently, or if there's something actually occurring in the substation that's making these alarms. That would be it for the Portuguese pilot. I hope I'm on time. Yeah, I'm not sure. I believe so.
Yeah,
These
indeed,
are the main two tools.
Indeed, Motaz, and thank you very much for staying within the timing, of course.
Thank you.
And for your presentation. I will invite. I'm inviting now audience to write your question in the chat if you have it. Meanwhile, I will take advantage for you to write in the chat to ask you, Motaz. Well, using drones in a substation, it's quite first of a kind in this also experience, isn't it?
Indeed, it is. It's something recent. I would say for more than 5 years, several entities start to use a ground for vehicles, but using drones, it's something new. Considering of course, the high risk of autonomy of it, getting nearby a substation and lines and so on. But now we are piloting this, so it's recent, it's new, and it will be a breakthrough course because with the drones you can more or less access different angles, even from the top. That can give you even an advantage about that. So we're exploring the advantages, yes.
Yeah. Indeed. Do you think it is? Do you think that it's easily, or at least it is feasible to replicate or to scale up also to other DSO or even TSO?
Yes. The idea is that with the recent new tools that you can, with just some AI support tool that can automatically convert your substation to trajectory points, and it will be just a matter of connecting these trajectory points, and the drones will autonomously drive through all these trajectory points. So we can scale up from small substation to a larger substation. And even that's the advantage, I would say, that you can use the same drone with the same tools, with the same equipments, for not only for the substation, but also for the overhead lines. So it will be just a matter of draw the line for it, and it will go through the whole network, detecting the images that you want, and it can be one tool analyzing everything. So in a scalable point of view, it's not a matter of question, it's something can be guaranteed.
Great, thank you. On this respect, we have a question from Juan Camilo Castaño. Thank you for your question. He's interested to know something about the other use case on overhead lines. He's asking who is driving the drones. How do you define the profile of the pictures that you want to take and analyze? And finally, how are you sorting the collected information to feed the AI algorithm? So 3 questions in a row. Who is driving the drones first?
So basically, it depends on the country and the regulation and the constraints, I would say, on the country. For example, in Portugal, first of all, the entity that is basically operating the drone should have a license and an insurance, and also the driver license, let's say, for the operator himself. And once you have that, and in our case, in the first use case, it was Lablek, and on the second case, it's a contracted entity that R²D² is contracting to do. So it's a third party. That's for the first question. Once you have the license and once you have the insurance covered, you can start and of course you have to do the GDR, the data declaration to ensure that you are not, let's say, by mistake, taking images of people. At least that's how they would say the lowest risk. But yeah, that would be for the first question. The second question, please, Ugo.
How do you define the profile of the pictures that you want to take and analyze?
So this is still, I would say, a process on detecting what angles we are trying to cover. But at this stage, since it's a pilot stage, we are mainly focused on taking all the angles of the assets, all the assets in the substation. We are not picking up in a large one. Like in total, we have 74 elements inside the substation, 30 in high voltage, in 60 kV, and 43 in low voltage side. So we are picking on all the assets, and it's another process, let's say, to characterize and check how we're going to profile this. And the third question?
And the third question was, how are you sorting the collected information to feed the AI algorithm? If in any point you want the help of our colleague.
I think this one I will read, yes.
Yeah, because ETRA developed the AI algorithm. Yes, Lucas, if you want to jump in. Hello.
Yeah, can you hear me now?
Yes.
Okay. Yes, with regards to the management and sorting of the information collected in the inspections, it basically it depends. For the LiDAR data, geographical information, geopositioning of the cloud of points is already present in the information capture. So we basically use this information to identify the location of the potential vegetation encroachments, basically using data of this cloud of points. And for the other type of inspection, those based on thermal and RGB images, we are using the geoposition of the images. In this case, it is the location of the poles of the pylons is predefined. We know this location based on the data given us by the operator, and what we do is to assign or associate the images to the different pylons according to the proximity of the geographical coordinates. And then we cluster the images and we associate the problems in an image to the closest pylon or electrical tower within the geographical data we have. And that's how we perform this sorting or association. I guess this was the information you need. Okay.
Thank you, Lucas. Thank you very much. Anyway, Juan Camilo, if you have, if you want to know more, as I told you before, I will share our contacts. Oh, okay. Maybe if I can complement also regarding your first question about who is driving the drones, since we made in the past some preliminary experiments in the early development of the tool, this particular tool within EMMA product is if I may say, kind of vendor agnostic. I mean, it doesn't matter who is driving the drone or the technology, how you acquire the images, the brand of your drone or whatsoever. In any case, as Motaz said before, until you sign a licensed pilot. And in our case also, since we're talking about thermal images analysis, the pilot used to have, or maybe not, but in our case, they used to have also, they're enabled to analyze thermal images. They have to do a specific course, specific training before acquiring these images. And until you sign a pilot with such characteristics, it is fine for the images to be analyzed by EMMA. More questions for Motaz? If not, let me check also the Q&A. Okay, seems not, Motaz. Thank you again for your presentation.
Thank you.
Okay.
Sharing.
Yes, please. So I would like to ask to Mateus to come back here with me, if you can. Hello, Mateus.
Hi, Hugo.
Thank you again.
Yes.
Okay, now let's see what was going on with the poll. Let me share my screen again. 1 second. Okay, this is the poll that we launched at the beginning of the session. So first question, according to your experience, which are the major challenges related to power system resilience? Multiple choices were allowed in this case. As we can see here from the stats, the percentages, the increased penetration of renewable energy sources has not so good feeling among stakeholders. I mean, I'm pretty sure that we are representing almost all stakeholders here in the energy industry, and well, the percentage are not so quite balanced. There's not so differences, but you can see the rest penetration followed by extreme events. In the general perception of the audience, at least in our small statistic, has the best or the worst feeling among partners. It is quite interesting that renewables that seems to save us during the energy transition as this double edge, double face. What do you think? What is your opinion on this, Mateus?
Thank you, Hugo. I mean, in fact, this in a way further emphasizes what I mentioned earlier and the beginning, Hugo, about aligning decarbonization targets with the resilience targets. I mean, we see that it is of concern this increasing penetration of renewable energy sources, and indeed this is highlighted in many documents, including the European standards and roadmaps that are published recently. I mean, this is a challenge indeed, and in many working groups that I lead or participate, indeed they're talking about stress testing this kind of renewable reach, close to 100% renewable, which 100% seems like a huge target. But indeed, I mean, these holistic stress testing approaches, taking into account the increasing penetration of renewables, also in combination with extreme weather and cyber attacks, and also the increasing penetration of distributed energy resources there, Hugo, is interesting to see, like 1/5. Of course, it was a multiple choice response, but 1/5, about 20% highlights that as well. It's important to note, I mean, there is a follow-up question there about understanding the role of DRs, but also the complexity they can bring, including the need for upgrading our protection settings, the coordination between distribution and transmission networks, and so on, Hugo. So this gives a nice picture of the challenges, let's say.
Yeah, indeed. On the other hand, we can see that physical attacks or damage of the equipment is not perceived as the most relevant menace or threat in the power system, despite we're always talking about critical infrastructure. Because power systems are indeed critical infrastructure, the physical attacks does not seems to be the most critical part here. On the other hand, the cyber attacks, yes, we touched briefly before the surface attack is expanding as the digitalization of the system is increasing day after day. Moving on to the second question concerning the flexibility coming from renewables and distributed energy resources in distribution system, which of the following two statements do you most agree with? It should be actively used for resilience and security procedures too, or priority should be given to full exploitation of for market and economic goals? Well, here it is quite evident the results. If I have to be honest, the most of the project, especially in our small words of Horizon project, many of the project dealing with flexibility exploit the flexibility for market reason, for energy communities, for ancillaries, and something like that. But some specific use or solution for resilience in emergency conditions, not always. What do you think, Mateos, if you can complement this?
Yes, I agree, Hugo, and I mean, to be very honest, I mean, when I voted for resilience security in the poll, but I'm quite surprised to see such a big difference between the two responses, which further highlights the need that for resilience, for using and leveraging, let's say, the flexibility for resilience and security procedures. I agree with you, Hugo, that there has been and is still a big ongoing research and innovation topic about exploiting the flexibility for market economic goals. But I think we can do much more about how to basically leverage and build on the flexibility of the DRs for security and resilience. Of course, we need to back that up with proper regulatory and market standards to enable the participation of DRs and renewables for the resilience security targets.
Yes, indeed. Thank you. Meanwhile, I remind to all the audience, if you want to raise any question anytime, we still have time to take your questions. So feel free to use the Q&A box. I see a question from and before moving to the final question in the poll, I see a question from Enis Dernedar. Sorry to mispronunciate your final name. I hope did it. I do it well. Anyway, Enis is asking, considering that the R²D² project preliminarily focuses on DSOs, are there any plans to expand the scope of applicability of the developed solution to TSOs, especially given the increasing role TSOs play in integrating distributed energy resources and ensuring overall system stability and flexibility? I can give a first answer to you, Enis. Indeed, R²D² also involved TSO. We had another, maybe this event is more focused on DSO, but we include in our pilot sites also TSOs. We had the Serbian TSO EMS involved in our partnership, in our consortium, sorry, along with the Serbian Regional Security Center, SCCC, and the RTE International, which is the technology company within RTE, the French TSO. We had another event approximately 1 month ago in a secret session focused only on TSO solutions. In this case, this event was more oriented to provide visibility and feedback on what we have developed regarding the DSOs. So yeah, I agree with you with the role of TSO within the project website and repository. You will find our solution also for TSOs. And
Ugo, if I may add,
yeah, sure.
Basically, from the C3PO perspective, I mean, the tool that we were mainly involved as University of Cyprus, I mean, the tools we developed with regards to the event simulators coming to windstorms and other events, but also the cascading simulators are very much applied to transmission networks as well. So they're kind of system agnostic. So regardless of the voltage level or the geographic location of the event of the system, they can be very much applied on transmission networks. And also, as Fanny has shown earlier, I mean, we can also evaluate the benefits of more and more distributed resources in transmission networks for enhancing operational flexibility and resilience.
Yeah.
Thank you, Ugo.
No, indeed. Thank you. Okay, then the final question, what is your perception on current European legislative and regulation framework on power system resilience? Here also the percentage are quite clear. Generally speaking, the audience has a good feeling about the current European regulation legislative framework. We know that several new regulations have been issued in the last years recently. The critical about critical infrastructure, critical entities, the CRA also, which come in force in a while. So I think even though some gaps maybe are still there, feedback about legislation, it's quite clear. Mateusz, what do you think?
Yes, I totally agree with the response, Ugo, from the attendees. I mean, overall it is good, and there are also being some initiatives currently being on their way to actually embed explicitly resilience into operational planning and also investment planning for both transmission distribution networks. and a number of the R²D² partners who also participate as advisors and consultants to regulatory policy bodies in Europe, and also we have advised NSOE and NSOE, and also Ofgem in UK and so on. So we know from first hand, Hugo, that there is indeed some movement towards the direction of clearly, explicitly integrated resilience into standards and regulatory frameworks.
Thanks for complimenting Mateos. So moving on to our conclusions, some lessons learned from our project. Well, first of all, reliability must be improved with a comprehensive resilience approach, meaning that considering this evolving scenario from more and more increasing extreme event, it's no longer a matter of how to avoid an outage will occur. It's rather than what we can do when the extreme event will happen. How can we minimize the impact? This is quite a paradigm shift, indeed, I think, which also implies some strategic reorientations in terms of how to handle the risk assessment, also when considering the risks for a critical infrastructure like electric grids, electric networks are. Mateos.
Yes, I totally agree with this comment, with this conclusion, Hugo. I mean, we need to, as you have in the slides, to reorient and perhaps move to more resilience paradigm, if you like, complementing reliability. Of course, the two concepts conceptually as well. I mean, we did a lot of work and try to compare them, understand what they mean, and so on. It doesn't mean you are one or the other, but they go together. So I totally agree with this point, Hugo. Yes.
Then another note that I took is the role of the microgrids as resilience enablers. Well, we've seen before in the Greek pilot presentation, how microgrids can intervene also in the prevention of the impact minimization when an extreme event like a windstorm may occur and may impact the system, albeit some limitation may arise also when we're talking about the regulatory complexity of establishing microgrid involving more stakeholders apart from the DSO, so involving also aggregators and RES owner and in general owners of distributed energy resources. I will complete this slide because we're running out of time, and then I will ask you one final feedback, Mateos.
Of course. Yes.
Then we have the value of the multiple stakeholder partnership when dealing with assessing the risk assessment. As I told you before, it's no longer having also expertise from power systems. An impact like the one that we suffered in Valencia at the end of October, as need to have several expertise, several different stakeholders contributing to assess the risk, because the impact is way beyond the pure electricity infrastructure. Of course, it affects economics and society and so on. And then another point that we touched briefly before, that are the investment in grid resilience. Of course, there is this kind of elephant in the room that is the Iberian blackout from 28th of April. We can maybe say, or maybe not, also in relation with this perception about RES as a threat that we see before in our questionnaire. And also this also links me to one of the latest news about a European grid package that it is supposed to be issued by the 2025 that will ask for more strategic investments in terms of interconnection, increasing renewable share, bottleneck elimination, and so on. So, Mateus, I will ask you one final consideration.
Yes.
If you can resume.
I will be very
your
short,
major...
Ugo. Yes.
Yeah, thank you.
So with regards to microgrids and in general, I mean, aggregate distributed energy resources, indeed, I mean, it was highlighted in the poll earlier that is very, very important. Also, through our work, Ugo, we took it a step further, looking at network microgrids, work that we did at the University of Cyprus and also colleagues from the PRECOG London, to see basically how neighboring and adjacent microgrids or DNOs can actually exchange resources during an extreme event to collectively respond and react to an event. I will jump to the last point, Ugo, on the public investment grid resilience. Although we all appreciate this, we need that. There are many challenges when it comes to, for example, doing a holistic cost-benefit analysis on investments and how you actually attach, let's say, probability to this event, because in all the MBAs, you need to include the probability of an event happening. And that is what troubling a lot of decision-making bodies, how to actually attach a probability to these events in order to justify properly, holistically, an investment in this kind of extremes. One approach can be you simply accept that this event will happen and you need to plan against them and to provide protection against them. The other approach is that you need to follow the full economical approach, which is very challenging to do in this kind of high impact, low probability events indeed. And this proposal to adopt this European grids package, it talks about bottleneck elimination, as you mentioned there, Ugo, which very much aligns with this stress testing approach to actually identify the weaknesses and the bottlenecks of current and future power systems, especially considering the high penetration of renewables. Thank you, Ugo.
Yeah, thank you, Mateus. Indeed, if you apply, historical data for the probability of this event might happen, maybe
you don't justify
will not
investment.
Yeah, yeah, indeed. Okay, so I will ask 1 minute more of your patience before leaving you. We will share with you, we will reach you out via email, sharing you with another questionnaire. It's a very, very quick questionnaire. It will take 3 minutes, no longer. It is completely anonymous, but it will be very helpful for our project to obtain your feedback about the impact of the solution presented here before, just to know your opinion on that. So we will reach you out, as I told you before, sharing this questionnaire. You can see here right now the QR code and the link, and it will be included in an email that will be sent after this the end of this event, along with all the information of our project, our website, our email, if you want to reach us and ask any question that you have, our Zenoto repository, where we used to store any kind of outcome that we have of our project, and a brand new bridge use case repository where R²D² had a very prominent role here in developing this new repository, which is aimed to store all the relevant use cases from all bridge project. The most relevant use cases from R²D² project will be stored here in this new use case repository. I can see Raquel, my colleague Raquel, already pasted here in the chat the link for this questionnaire. We are few minutes late. So thank you all of you for your patience, for staying here until the end of the event. Thanks again to all the speakers that joined us today, and how I hope you could have seen some interesting presentation from our side. Feel free to contact us anyway. Thank you, everybody. Have a nice day.